Hello, and thanks for tuning in to this special episode of the OEM Industry Update, a podcast examining the latest news and technology trends impacting product development teams in the heavy-duty on- and off-highway equipment industries. I'm Chris Vavra, the editor of OEM Off-Highway, and I'm pleased to welcome our special guest today, Michael Schankin, Head of Creation and Engineering for EAO Automotive, in today's episode, The Importance of Functional Safety for Off-Highway Vehicles. Welcome, Michael. Thanks for joining me today.
Hi, Chris. Thank you. Appreciate the opportunity to talk to you today. Hi.
Likewise. So before we begin, why don't you tell us a little bit more about yourself?
So as mentioned before, my name is Michael. I've been working in the field of HMI since about 20 years now. I'm starting as an electronics engineer in the automotive industry. We developed and designed HMIs for OEMs like Audi, VW, or Bentley, for example. And since about 10 years, we're also in the heavy-duty special vehicle sectors. And there we are developing HMIs for heavy-duty special vehicles for trucks, tractors, and so on.
Sounds great. And with HMIs, with heavy-duty vehicles, functional safety is a major topic these days. So why don't you give us a little background on what is functional safety and what do our listeners today need to know?
I'll try that in easy words. So functional safety is the absence of unreasonable risks due to hazards caused by malfunction behavior of electronics and electric systems. That means functional safety is needed wherever electronic devices or systems help people to make their lives even safer or more pleasant. The main objective of functional safety is reducing the risk of personal injury. And that's really important because what is not in the scope of functional safety is damage of property or something like that. It's all about humans. It's all about personal injury. That's what functional safety cares about.
So what type of applications and functions benefit most from functional safety within the off-highway world?
We have a lot of applications where functional safety is needed in every application where somebody can get hurt or get personal injury from machines, most likely on machines that are moving, for example, garbage trucks where something is moving, or lifters, movers, everything where somebody can get an injury from. Their functional safety is really needed.
So, when it comes to functional safety, why is it required? And, when you talk about HMIs, what do manufacturers have to think about when it comes to functional safety in that realm?
Functional safety is kind of state of the art. So if you are the manufacturer of products used in this market, you always have to think about how to develop your product state of the art. And functional safety is kind of state of the art. So you always have to consider functional safety in this market because you have to reduce the risk to a minimum as far as possible. That's up to the manufacturer. So he has to care about functional safety.
And certainly, codes and standards relating to safety, regardless of, what industry, what country you're in, the functional safety ties in very nicely with the codes and standards of the day, correct?
Yeah, that's correct. You have different standards for the different markets in functional safety. You have standards for automotive industry. You have standards for the special vehicle sector. This is, for example, the ISO 13849. You have different standards for agriculture and so on. But at the base of it all, it's all about functional safety, and they're all basing on the ISO 61508.
And, could you give like an example of how would it be different for agriculture as opposed to, say, construction or mining? Are there some key differences that are when it comes to functional safety?
No, not really. They have small special things in these standards, but in the big picture, they are all the same. You have to keep to a certain process for developing, also for manufacturing. But there are some documentation, for example, is on some point different because the different industry want to see different documents for the functional safety. But in the big picture, it's everything the same.
Sure. So safety integrity level is something that is not unfamiliar to, I think, most manufacturers. But could you describe that a little, as well as what is a risk classification process?
The safety integrity level is a measure of the safety in the safety-related system. It indicates how reliable a system is and if it is able to carry out safety-relevant functions in order to minimize the risk. The most common shortcut for that is SEAL, the safety integrity level. This is from SEAL 1 to SEAL 4. With CL4 representing the highest safety level and placing also the strictest demands on the reliability and also on the availability of the system. These risks are typically classified in a risk analysis, also called hazard and risk analysis. And this takes into account various factors, for example, the likelihood of this undesirable event, the potential consequences of the event, and this analysis helped to determine the required safety integrity level for a system to ensure that it meets the specific safety requirements. That means not every safety system, safety function has the same requirements. Some are more critical because they can fail more often. Some are less critical because they can fail less. Sometimes the impact is also higher, so you have to classify your safety system at the beginning of the process, so you are going to the right direction during your development process.
So when it comes to off-highway vehicles, what is the common SIL that companies try to achieve as far as what is the standard that they should be aiming for?
The standard in our machine industry, heavy-duty special vehicle, is the ISO 13849. This is in Europe the common standard used for this industry.
Right, and and in terms of safety integrity level, what does that equate to for the off-highway industries?
Safety integrity level in the off-highway industries regarding to this norm or standard ISO 13849 is called the performance level. This is at the end is the same as a safety integrity level, but they call it performance level. This is going from A to D, likely the same as a SEAL level. Yeah.
Okay. Now another topic, data buses. What are some of the pros and cons of data buses within heavy duty applications? How does this relate to functional safety?
In traditional electromechanical systems like we had the years before, they are gradually replaced by complex electronic systems. The reason for that is the increasing demand on functionality of the systems, and so also on these components. And so in a traditional hardwired system, you need hundreds of wires to connect all the HMIs with the ECUs or with the motors and so on. And for example, for a keypad with 6 buttons, as we are a manufacturer of, you need 13 wires if it's hardwired. So that's where the bus systems occur and need to be put into the machines. And in a CAN bus system, for example, you can connect up to 128 components, and for that you only need 4 wires. And this is why you can significantly reduce the amount of wiring, which at the end also saves money and also saves time. And that is why data buses are so common for these heavy-duty applications. But this increasing complexity of the system will also lead to a new type of malfunctions. For example, in a traditional system, you have to cut a wire so that the button or the switch doesn't work anymore. But if you have a CAN bus system, for example, this system can already be disturbed by electromagnetic interference, for example, a radio device or something like this. This can lead to disruptions in the data transmission, and this can cause the application to enter an unintended state. And for these reasons, you need more and more methods to avoid or detect such errors. And this is where the concept of functional safety becomes crucial.
What role is artificial intelligence playing in helping improve functional safety? Because we can't get away from AI. So I was wondering, is AI helping with functional safety?
I don't know. We are not using AI at the moment for our systems. I think this will become more and more important using it, but in the case of functional safety, I think it's a bit critical because the functional safety processes, they are all really strict. You have to keep your process according to the V model. I think that's a common sense in the industry. And AI is something that is not always predictable in at the end. So I think, yeah, we have to take a closer look at that in the future.
You had mentioned your certified keypad a little bit earlier. Could you describe that a little bit more and what role that plays with functional safety for off-highway vehicles?
Our keypad, we launched now in this premium version, the certified version. I think it's this year. It was this year or the end of last year, and this so-called premium variant gives the customer the opportunity to use a Schankin keypad in a functional safe application. And the fact that this keypad is already certified for functional safety significantly reduces the development and certification effort for the customer. That means he has not to think about how is our keypad made, how was the development process. It's certified, he can use it, he can put it in his application, and he doesn't have to take a closer look at during his development and certification process. So it makes this whole process a lot of easier and faster for him. That's a big advantage of our keypad.
So I guess for a final thought on functional safety, what is the one thing, people in the off-highway industry, whether they're an OEM, an end user, C-level or on the ground, what's the one big thing that they should be emphasizing when it comes to functional safety?
I think the functional safety is not really common all over the world at the moment, but you have to be sure to consider all these functional safety things also on the higher levels at the manufacturers, because it's not only helping the user or the customer for his products and his application, it's also helping the manufacturer of the keypads to state that his product is really safe, it's developed according to certain standards. He can prove that he did everything to minimize the risk as low as possible. And it's kind of security also for him to say, okay, what I did was correct. I did it according to a standard. And so I'm according functional safety and the risk is minimized to a lower level.
That's the name of the game in the off-highway industry and any, I think, manufacturing industry. Keep the downtime and keep the personal risk as minimal as possible. Yeah. So, some good stuff there. So, I want to thank you, Michael, for taking the time today to join me on this podcast and sharing some of your thoughts on functional safety and how they relate to off-highway vehicles and the off-highway industry as a whole. So I appreciate you taking the time today to join me.
Thanks again for the opportunity. Thank you.
So that does it for today's episode. Listeners, thanks for tuning in to this episode of OEM Industry Update. Be sure to visit OEMOffhighway.com for more episodes and more industry insights. And again, I'm Chris Vavra, the editor of OEM Off-Highway, and I'll see you again very soon.